Let's take a look at the application of radioactivity. So we talk about alpha, beta, and gamma, three kinds of ionizing radiation, and let's take a look at this example and see how human manipulates the property of ionizing radiation to do all these things. So what I want you to do is, I want you to finish page 11 by reading the textbook on these two pages, or if you can't find the answer, you may want to Google it. Help me to find what are the relevant or suitable ionizing radiation source. That means alpha, beta, or gamma for each of these applications. And also try to find out the difference between gamma ray and X-ray. Pause the video and do it now. Okay, so here is the answer. So what we have here is for medical tracer, it will be gamma ray. I will recommend you to watch this video. I'll put the link in the description. It's a very old video, but then it's still amazing to see how it's been put into medical work. So basically, I think this boy has some sort of heart disease issue. So in his, if you learn about biology, you know in the heart there are 4 chambers, and what happened to him is between the chambers, there are some leakage between the chambers, so the blood will not flow properly like how we usually do. So that's why some oxygenated blood will mix with the deoxygenated blood, and that's something to do with his own body. So using the medical tracer by putting the gamma ray source into the blood will be very helpful. So again, I will encourage you to watch this video and how also this technician would deal with the substance as well for safety issue. The reason why we chose to use gamma is simply because gamma ray, if you remember the penetrating effect or penetrating power of gamma ray, would be quite penetrating. Well, it's actually the most penetrating, while for alpha and beta it would not. So think about if you swallow this or if you inject this in your blood, with alpha and beta, you are more like killing yourself because you cannot detect alpha and beta outside of your body because it got blocked by your skin or internal organ. But then for gamma, it will be not as harmful, but then you can still detect it outside using other machines. So that's why we chose gamma, which is very sensible choice. Next is to test for the cracks and also monitoring the thickness. In fact, I will say these two are very similar, but you can see they use different kind of radiation, and that actually depends on how thick, like how long is the distance you are trying to measure. For crack, probably they are talking about things like of the building or like really thick material. Then you want more penetration power, so gamma will be a better choice. For thickness, like monitoring metal sheets or even paper, it will be quite thin, so using beta will be quite useful, rather than gamma may not give you a lot of significant change in that case. Next one is called carbon dating. It's nothing to do with, of course, this picture. This picture is a joke apparently. If you try to read the textbook, it's basically those archaeologists. I'm not sure if you are interested in that. Like those people finding out, really old stuff from the soil, from the land, and they try to find out. So how many years ago? Think about how could we actually know things from million years ago or at least 1,000 years ago. So the way that we use is called carbon dating, using something called the carbon-14. If you know about chemistry, you know the usual carbon that we have is carbon-12 in our body, which consists of 6 proton and 6 neutron. For carbon-14, it is the isotope of carbon, and apparently it also has 6 proton because it's also carbon, right? And that actually means how many neutron? 8 neutron in that case. So this one is unstable, so that's why it will emit the radiation. You may not be able to find beta in your textbook, but if you try to Google it, you'll find out the reaction is emitting beta. I got a simulation here, which I think I would make it in a separate video in the next part. So if you're interested, make sure you watch that video as well. I think it's very interesting game for you to play in maybe 15 minutes. Okay, so make sure you watch the next part for that. The next one is the smoke detector, and then the smoke detector actually is radioactive. I'm not sure if you know. So or actually I'm saying for some of the smoke detector, maybe nowadays is maybe a bit different, using more electronic stuff, but in the past people use the alpha source to make the smoke detector, and that's why you can see this picture showing there's a radioactive symbol in it, because you don't want to touch it, especially for alpha, because that is going to ionize your skin. That means damage your skin so hard. The picture I can show you is something like this. I mean, this is like usual smoke detector that you may find maybe when you go to a hotel or anywhere. I think for the one in school is not radioactive, so it is safe to touch it. For the internal structure, here is a diagram. You may want to take a look. So what happened, how it works is simply you can see there's a radioactive source here emitting alpha. So imagine it keep going up. What it does is these are the air, and you know alpha can be very ionizing. In terms of the three, alpha, beta, and gamma is the most ionizing radioactive substance or radioactive source you can have. So what it does is it will ionize the air that you have, so that the currents can pass through it. You can see there's a battery here, so the current can pass through it. And this is a normal case when the air can be ionized. If you don't understand what it means by ionizing, that I can explain to you very quickly. Think about this: H2O, right? The simplest chemical probably that you know. It's actually made of two things in terms of ions. It's made of H plus hydrogen ions and also the OH minus, right? So these are the two ions. So that means if you somehow try to ionize the water, then the water will become these two instead, or become these ions. So back to the picture here, then what happens is the currents can normally flow through because they are ions. Ions means they are conductive. While for normal air, they are not conductive, apparently. Otherwise, if air is conductive, then everyone would die, because the electrical outlets will simply send the current to you, probably. Yeah, so normal air is not conductive, but for the ions, they are conductive. So the whole system works this way. The current usually flow through this circuit, and that's fine. Think about this: when there's a smoke, so smoke is much bigger than air. Think about this: you cannot see air, but you can see smoke, because smoke are much bigger particle. So imagine there's a bigger particle here. The alpha would not or may not be able to ionize it because it's so big, so huge. So in that case, it will block the circuit. And think about what you learned in the last chapter in logic gate. Surely you can set up a certain logic gate so that it will make an alarm to trigger the sprinkler, or at least a bell, or etc. So this is how it works. By manipulating the radioactive source. Okay, before nowadays I think we got electrical sensors, so probably they rather not to use radioactive substance right now. But this is how it works in the past. Okay, the last question on page 11 is asking you the difference between gamma ray and X-ray. And so the main difference is that they have different wavelength. So like the picture here, they have different wavelength, as we all know from chapter 9, I think, or chapter 7, is it? So you have the X-ray here, gamma ray here. Actually, there are soft X-ray and hard X-ray. And in fact, if you try to look at maybe different sources online, here for convenience, I just use Wikipedia allow me to do that. So it said actually there's no consensus for a clear definition or clear distinguish between X-ray and gamma ray, except there may be a belief on the frequency or wavelength should be a clear cut. So gamma ray must be the one with higher frequency. The other difference that you may think of is for gamma ray, usually or most of them are from the nature. Alright, we got a lot of gamma ray from the outer space, alright, to the earth, or we call it cosmic ray. The only artificial source that we could have for gamma ray is by fission, so the nuclear fission you just learned, the nuclear reactor, etc., or doing some physics experiment about the quantum mechanics or nuclear fusion. Okay, so for X-ray, however, basically most of the X-ray on Earth are artificially made, like those in the hospital apparently. So these are the main difference, and in fact both of them will be harmful to your body if you receive too much. Okay, so this is the main difference of that. For the next part, I would like to ask you to do the next page 12. Pause the video now and we will check the answer. Okay, let's take a look of the answer and work it out together. So it tells you that alpha, beta, gamma, yes, are all ionizing radiation. They've been very kind to tell you this. What happens when gases are ionized by the ionizing radiation? So like we said, the electron, when we talk about ionizing, be careful, but by the way, radiation is basically everything in the EM spectrum. So that means infrared, as we said, is radiation, UV is radiation, even microwave is radiation, radio wave is radiation, everything is radiation. But when we talk about in this chapter 11, we talk about alpha, beta, gamma. These are ionizing radiation. That means they are able to ionize stuff, and that actually means the electrons would be ripped off from the atom itself. So this is the idea of ionizing. Next question, it asks you why alpha is considered better ionizer, more ionizing than beta. So there are different ways of saying it. You may say that alpha in itself has a more charge, +2. Beta is -1. So in terms of absolute charge number is greater. The other thing that you may talk about is alpha has greater mass, and while beta has less mass. So in that case, it would be, it will be more effective. Or you can also talk about it. Actually, I like to say this more. It's slower, and therefore it's more ionizing. Then you may wonder how come? How is speed related to ionizing? Think about this. When the alpha particle passing through the air, it will ionize, the things. I mean, it's not a very good drawing here. I mean, I shouldn't draw this line, but then imagine like it's trying to take some time to interact with the air particles in the process of ionizing. If you try to move slower, then you get more time to interact with each particle. While for beta, imagine that, all right, it just moves so quickly that it simply fly away before it get to interact to each person. Imagine that it's a bit like there are two people walking in a room. Alpha much slower, and then alpha got the time to talk to the people nearby by passing through the crowd. For beta, it's like rushing through the crowd, and there's no way that beta can, or very unlikely that beta can talk to the crowd. I mean, other people in the crowd. So that's the idea. So either way, you can say that too. For part B1, it asks you to suggest those practical application. Basically, is the one in the previous page. So you can name any of them. Any of them is fine. And it asks you to suggest, well, for one of the applications, you suggest describe how it works and draw a diagram to illustrate it. So I think it doesn't really matter which one you use. I would personally prefer maybe the thickness or cracks monitoring or test will be easiest because it's simply easy to draw. Okay, so for example, here is a receiver, and here is an emitter for the source, let's say beta source. Alright, and there is a roller to kind of move the paper, like rolling this way, so the paper go this way. There's another roller, and then maybe there's something happen to the paper. Let's say there's somehow there is some quality issue, like it's not even in terms of thickness, and then once it roll, it would be able to detect. So you can try to describe in words here. So any of the description with the detailed diagram will be okay. If you don't like to draw this, I think medical tracer is also fine too. Alright, while for carbon dating is a bit hard to draw, smoke detector you have to draw carefully to make sure everything is correct. While for this, I think is probably the easiest, so I would suggest this one.